Alright guys, can you hear me? If you can hear me, let me know. If you can hear me, let me know. If you can see the board and you can hear me, let me know. Let's go. If you can hear me, you can see the board, let me know. If you can hear me and you can see the board clearly, please let me know. Is the sound audible? Alright, if you can hear me and you can see the board clearly, please let me know so we can start. It's already 8 o'clock. It's already 8 o'clock. So we can start, right? We can start. All right, good day, everyone. Welcome to today's class. Good day, everyone. Welcome to today's class. Let's wait for others. Let's give others 2 minutes to join so we can start the class properly. Is the sound very clear? Is the sound very clear? Let's give others 2 minutes to start. 2 minutes, 2 minutes, and kick off. Let's just give them 2 minutes. Then we're going to kick off. So today we'll be covering a lot of things. We'll be covering a lot of things today. It's going to be an exciting class. And we're going to be engaging too. So please be active. If you have any question, you can drop it either on the WhatsApp group or in the comment section. All right, so we'll be looking at the expansion of brackets. Number 6. We're looking at indices. We'll look at the laws. Number 7. We'll look at logarithms. And the laws too. We look at surds. We look at linear equations. We look at simultaneous equation. Look at quadratic equations. Look at what quadratic equations. Under these quadratic equations, we use factorization and the formula method. Then look at inequalities. Inequalities. So these are the topics we'll be looking at for tonight's class, for today's class. So you can take note of that. Algebraic expressions, factorization, that's common factors, look at the difference of two squares. We'll touch some examples on quadratic factorization. We'll look at the expansion of brackets. We'll also look at indices and their laws. We'll look at logarithms, look at surds, and we'll look at linear equations. We'll also look at the simultaneous equations and solve one or two problems on it. We'll solve what? Examples on quadratic equations using the factorization method and the what? Formula method. And finally, we'll be closing with what? Inequalities. So please make sure you stay engaged. You can chat in the comment section. You can chat in the comment section. You can chat in the comment section. Alright, if you're done writing, let's proceed. Let's proceed. If you're done writing, let's what? Proceed. If you're done writing, let's what? Proceed. Okay, first of all, what is algebraic expression? What do you understand by the term algebraic expression? Now, an algebraic expression is a combination of numbers, constants, letters. Now let's do this. Let's look at algebraic expression, the first one. Algebraic expression. Okay. Let me do it here like this. So algebraic expression, we're looking at this now. So for algebraic expressions, it is a combination of numbers, and these numbers are also called what? Constants. It's also a combination of what? Letters, also known as what? Variables. So we're talking about algebraic expression, combination of numbers, letters known as variables, and operations. Operations. When we talk about operations, we're simply talking about the what? Addition, subtraction, multiplication, and what? Division. Now, let's look at how we simplify algebraic expressions. Let's look at how we simplify algebraic expressions. So under algebraic expressions, let's look at what we call simplification. Now, for simplification, this involves the combination of terms. You can add or subtract terms only if they have exact same variables and power. So, if they have same variables, one, and same powers. Now, we say the variable is a letter, right? So, if they have the same variable and the same powers, now let's say a variable x, if we are given 5x and 3x, right? And here, let's say we are given 3x and 5x squared. Now, they said for you to add these two expressions, that's 5x and 3x, they must have one same variables, that's this x now. It must be the same here and here. And the power of x here is 1, the power of x here is 1. They must have same variable and same powers. But here now they have same variables but different. Power here is 1, the power here is 2. So here you cannot add them. Here you can what? Add them. So if you add 5x and 3x, you get what? 8x. Similarly, if you subtract 5x minus 3x, you get what? 2x. But for here, you cannot do the same thing when it comes to what? Addition and what? Subtraction of what? Algebraic what? Expressions. Of algebraic what? Expressions. Please take note of that. They must have same variables and same powers. So next up, let's look at substitution. Substitution, still under algebraic expressions. Substitution. Now for substitution, this is simply plug and play. We call it what? Plug and what? Play. So you put in the value, then you what? Simplify it. You replace the variables with a specific number. So now let's say they give you x. So you now replace it with a number, with any number you like. Now, let's take an example. Example. And you see how we simplify this algebraic expression. Now the question says, let's take an example. The question says, simplify 4x plus 7y minus 2 into x minus 3y plus what? 5. So now they say we should simplify this algebraic expression. Now, if you look at this expression, the first thing you need to look at is what? The bracket. So the first step 1, you what? Expand the brackets. Now, if we are to expand the bracket, please hope you're following. Hope the network is there and you can hear me and you can see me very well. Please. First of all, you what? Expand the bracket. To do that, you use 2 to multiply x minus 3y. We're expanding this bracket now. Now, if we do that, we'll have 2 times x, 2x, 2 times minus 3y, it will be what? Minus, because there's a plus before the 2, right? So then the plus times the minus will give you minus, then 2 times 3 will give you what? 6y. So that's the first step. The first step is to expand the bracket. So now we'll rewrite this equation after expanding the bracket. Our new expression will be 4x plus 7y. Now we put this here plus what? 2x minus 6y plus 5. Now the next thing is to do what? Group like terms. Group what? Like terms. Now, for us to have like terms, that means they must have the same variables, right? So now 4x and 2x, they are like terms because they have the same variables, x variables. Plus 7y and minus 6y, they are what? Similar. They are like terms, so you can group them. So if we group them, we'll have what? 4x plus 2x, as we have collected the x variables. Now we'll take the y variables, plus 7y minus what? 6y. Then we bring back this constant plus what? 5. So this is now our new arrangement. So now 4x plus 2x. 4x, okay, this is a minus sign. This is a plus sign. Let's take it as a plus, since we already use it as plus. So 4x plus 2x will give us what? 6x. 7x minus 6y. Now, remember I told you that you can only add or subtract them if they have the same variables, that's x variables, and the same power. So now we have x here, we have x here, and the power of x here is 1, the power of x here is 1, so you can add the both again to get 6x. Same thing here, 7y minus 6y. They have the same variables, which is the y variable, and same powers. So plus 7y minus 6y will give us what? Plus what? Y. Then we write our final value here, which is plus 5. So this is how we simplify what? Expressions. So next up, we'll be looking at substitution. Still under algebraic expressions, we'll take an example on what? Substitution. Still under this, we'll take an example on what? Substitution. So let's go. So substitution, take an example. So substitution under algebraic expression. So now we are given if A is equals to 3, B is equals to what? Minus 2, and C is equals to 5. Still under algebraic expression, we say we should evaluate A squared minus 2B all over what? C. So now this is an algebraic expression. It's an expression because it's not equals to any what value. So it's just an expression. So now to do this, our solution will be very simple. Since we're talking about substitution, we have A as 3, B as minus 2, C as 5. We simply what? Plug and play. Remember I wrote plug and play, right? We'll plug and what? Play. So now let's plug and play. We have that our new expression as A is what? 3. So we have 3 squared minus 2. B is what? Minus 2. All over C, which is 5. 3 squared is simply 3 times 3, which will give us 9. Now, we have minus 2 times minus 2. Minus 2 times what? Minus 2. Minus times minus will give us plus. 2 times will give us 4. So this will be what? Plus 4 over 5. 9 plus 4 will give us 13 over 5. So this will be our final what? Answer. If you do 13 divided by 5, you will still get a value, which will be what? 2.6. So we are done with algebraic expression. Under algebraic expression, we looked at what? Factorization, how to factorize algebraic expression, and now we look at what? Substitution, how to substitute and get your final answer in a simplified form. So next up, we'll be looking at factorization, different types of what? Factorization. Factorization and different types of what? Factorization. Let's go. So we're looking at factorization and different factorization. So number 2, we are done with 1. Number 2, factorization. So look at the part A of factorization, which is called what? Common factors. So common factors. Now take note, factorization is the reverse of expansion. Factorization is the reverse of expansion. It is the process of breaking and expressing. Wait, let me write it down now. Factorization is the what? Reverse of what? Expansion. Please take note of this. It's the reverse of expansion. It is the process of breaking an expression down into a product of its factors. Now, the first rule of factorization. Now, let's take the first rule of factorization. Before you factorize, you need to know this rule. The first rule of factorization is to always look at the highest common factor, which is the HCF. Highest common what? Factor. So now, after looking at the highest common factor, you look at every term in the expression and ask yourself, what is the largest number or variable that can divide both of them? Now, let's take an example. So you understand what I'm saying. If you have 6x squared plus 15x. Now, from rule 1, they said we should take the highest common factor. Between 6 and 15, we know that the highest common factor is what? 3. 3 into here will give us 2, and 3 into here will give us 5. So there is no other factor that can divide both of them. If you use 2, it will not go. It will go into 6, but it will not go into 15. If we use 5, it will not go into 6, but it will go into 15. If we use 4, it will not go into any of them. So 3 is the highest common factor that can go into both of them. So to factorize this expression, we simply get the what? HCF. Once we've gotten the HCF, now we'll now look at the factors of the what? Variables. Now let's look at the variables. Between x squared and x, what will divide both of them? What's the highest common factor between both of them? If we divide x here, x over x squared, x comes here, get 1 here, x will still remain with x. So you get x here and you get 1. So x is the HCF between what? This x squared and x. So we can say that the common factor method, our factor will be what? 3 and x. That is what? 3 what? X. And 3x into 6x squared, we have 6x squared here over 3x. 3 will enter into here to get 2. 3 will enter into here to get 1. X will enter into here to get x. X will enter into here to get 1, right? So we're left with only 2x. So we'll now have what? 2x plus, if we do the same thing here, 15x over 3x. X will cancel x. 3 here will give us 5. 3 here will give us 1. So we're left with what? 5. So this is how we what? Use the common factor method to simplify this expression, to factorize this expression. So this is the factor of this expression. Now another type of factorization we'll look at is what? Factorization by what? Grouping. Factorization by what? Grouping. So let's look at that one. Factorization by grouping. Factorization by what? Grouping. Now, for factorization by grouping, if we're given, let's say we should factorize ax plus ay plus bx plus by. Now, first of all, we factorize the first pair. Now, for this first pair, we're going to factorize by grouping. The first pair will be ax what? Let's write it here. The first pair is what? Ax plus y plus ay. If we are to factorize the first pair, what is common between both of them is a. So we'll write it here, ax over a will cancel a, we'll be left with x. Ay over a will cancel a, we'll be left with what? Plus what? Y. So we are done with the first pair. We have a into x plus y. So next up, we what? Factorize the what? Second pair. Now, for the second pair, you know we are factorizing by grouping. So this is the second pair, which is what? Bx plus what? By. Now, to get the common one, we'll do what? Bx divided by what? Since b and b is common here, we'll divide it. B will cancel b. We'll be left with b into what? X. Now let's do for by divided by b. Since b is common between both of them, b here will go, b here will go. So we're left with what? Plus y. So we are done with this. We have factorized them by grouping. So the next thing to do is to do what? If you notice, x plus y is here, x plus y is here. So x plus y is their what? Common factor. Next up, we will rearrange it. We will now have what? A plus b and what? X plus what? Y. So now we factorize this expression by grouping. We what? Took out the first pair, brought it here, look for the highest common factor between both of them, which was A. We took out the second pair, we brought it out, we looked at the highest common factor between the both of them, which was B. Then we simplified. We found out that x plus y is common in first pair and second pair. So it's the factor of what? We factorize it out to now be what? A plus b into what? X plus y. And we say that factorization is the opposite of what? Expansion. So if we expand these two terms, we are going to get this. So since we are doing the opposite, we are getting what? This. So let's move on to the next thing. Difference of two squares. Difference of what? Two squares. Let's look at difference of two squares. Difference of what? Two squares. Number 3. Difference of two squares. Now, for this is a very specific pattern. You should train your eyes to spot instantly. Difference of two squares occurs when one perfect square is subtracting another perfect square. The rule is very simple. Let's say we have a square minus b square. This is a perfect square. This is another perfect square. So when one perfect square is subtracting the second perfect square, we will now have what? A what? Minus B and A plus B. This is very simple. Now, take note. The key requirements for difference of two squares. Write it down. Key requirements. The first one is there must be what? There must be exactly two what? Terms. Now, this one we have A and B. So there must be exactly two terms. Secondly, both terms must be perfect squares. Both terms must what? Be perfect squares. When I mean perfect squares, I mean 1, 4, 9, 16. All these are perfect squares. These are perfect squares. These are perfect squares. 25 x squared y raised to the power 4. They are all what? Perfect squares. So it's a requirement for difference of two squares. Now the third one is there must be a minus sign between them. 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 Note, if you have something like this, a squared plus b squared, this will not work. This cannot be factorized using what? Difference of two squares. We only have three requirements for this to work. The first one, exactly two terms. If it is more than two, it will not work. Next, they must be perfect square. One is a perfect square. 4, the square root of 4 is what? 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of x squared is x. The y raised to the power 4 is what? Y squared. So I see they are all perfect squares. And finally, there must be a what? Minus sign between them. So next up, let's look at some examples. Let's look at some examples. Factorize x squared minus what? 49. Now, first of all, step 1, solution. We'll look at the first step. Is this a perfect square? Yes, it is. So for x squared, we have x as a perfect square. For 49, we have 7. The square root of 49 will give us 7. The square root of x squared will give us x. Now let's look. Is there a minus sign between both of them? Yes. There's a minus sign. Now, are there only two terms? Yes, there are only what? Two what? Terms. So the requirements are what? Complete. The requirements are what? Complete. So we now have that what? X squared minus 49 will give us what? X minus what? 7 into what? X what? Plus 7. So this is what we do when you see a question like this on difference of two squares. You don't need to waste time. Just check if the requirements are there. And if the requirements are there, then you proceed to calculating. So next up, let's look at one more example. Let's look at one more example, then we'll move to the next one. Now, this example says factorize 16y squared minus 81z squared. Now our solution will use the same strategy. Now we have 16y squared, 16y squared, we have 81y squared, we have a minus sign, and we have two terms. So now let's check if these are perfect square. We already have a minus sign, so this is correct. We have two terms, this is correct. Remaining these two. The square root of 16 is what? 4, right? Square root of what? 16 will give us 4. The square root of y squared will give us what? Y. This will give us what? 4. Now, the square root of what? 81. The square root of 81 will give us what? 9. And the square root of what? This is z. This is z. And the square root of z square will give us what? Z. So they are all what? Perfect squares. So we get here 4y and we get what? 9 what? Z. So we can see that this equation, this expression, 16y squared minus 81z squared will be equals to what? 4y minus 9z into what? 4y plus 9z. So we simply apply the what? Difference of two squares to this example. Very simple. Next up, we look at quadratic factorization. Quadratic factorization. Let's go. Quadratic factorization. How do we factorize quadratic? So for quadratic factorization, the basic concept is very simple. A quadratic expression usually take the form ax squared plus bx plus what? C. This is the form when what? A is equals to 1. Once you see this, you know that it's a quadratic factorization. Product. Take note. For sum and product, the goal is to do what? Multiply to give the constant term and what? Add to give the middle coefficient, that's b. Now, if we take the coefficient now of this and this, the constant term is c. Take note, the constant term, c is the constant term. So, if we take the coefficient of x squared times the constant term, the coefficient of x squared is what? 1 times c, give us what? C. So the first step is to what? The first goal, multiply to give the constant term c. And the next one is to what? Add to give what? The middle coefficient add to give the middle coefficient, which is what? B. Coefficient, which is what? B. So this is the middle coefficient B. So let's take an example. We have x square plus 7x plus what? 10. Now, 10 here now is the constant term. So if we do 10 times the coefficient of x here, the coefficient of x is 1, right? So we'll now do 1 times 10, which will give us what? 10, which is the constant 10. And our middle 10 is what? 7. So now, what are the factors of 10? What can divide 10? We have 1. 1 can go into 10. We have 2. We have 5. And we have 10. Now, the next step is to look for two numbers that will add to get what? The coefficient of the middle 10, which is 7. If we add 1 plus 10, it will give us 11. It cannot go. If we add 2 plus 10, it will give us 12. It cannot go. If we have 5, if we have 2 plus, if you add 1 plus 10, it will not go. If you have 2 plus 10, it will not go. If you have 5 plus 10, it will give you what? 15. It will not go. We are looking for 7, right? So now let's do the next one. 2 plus 5 will give us what? 7. So we have found it. So we have fulfilled the second law, which says R to give the middle coefficient, and the middle coefficient is what? 7. So we have two factors of 10, which is 2 and 5. So we'll write our expression as what? X squared plus what? 2x plus 5x plus 10. So this is our new what? Expression. So if we simplify, remember we talked about factorization by grouping. So we take this one as one group, we take this as one group. So from this group, we have x as common between both of them. So we'll bring it out. X divided by x squared will give us what? X. X divided by 2x will give us what? Plus 2. Now we also have the second group, which is 5x plus 10. If we take what is common between both of them, x plus 10, 5 can go into here to give us x and 5 plus 2. So let's write, we have that plus 5. 5 into 5x will give us x. 5 into 10, when I mean into, I mean divided by. So 10 divided by 5 will give us what? Plus 2. So now, look, we have x plus 2 is here, x plus 2 is here. They are common, right? So we'll take them out because they're the factors. We'll now have our quadratic factors as what? X plus 5 and x plus what? 2. So this is how we what? Factorize using quadratic factorization. Very simple. These are the steps. These are the goals. 1, multiply to get the constant term. So next up, we'll be moving forward. We'll be looking at expansions of brackets. Expansions of brackets. Now, we'll be expanding. Let's expand something. Let's expand something. We'll be talking about factorization. So now let's look at expansion. Let's look at one expansion before we move to indices, before we move to a lot of indices and logarithms. Alright, so from, let's look at number 5. What was our outline for number 5? Expansion of brackets. Alright, expansion of brackets. Let's go. Expansion of brackets. Expansion of brackets. After expansion of brackets, we look at indices laws, then we look at logarithm laws. We'll be moving very fast. So number 5 is what? Expansion of brackets. Expansion of what? Brackets. Now, let's say we have 2x is an example, right? So 2x plus 3 into what? 5, x minus what? 5. And we are asked to what? Expand this bracket. So the first step is to what? Take out this 2x, multiply by everything to the first bracket, second bracket, which is x plus 5. Take out this plus 3, multiply it to everything in the second bracket, x minus 5. So now, please, this can look very simple, but it's very tricky because of the signs. That's why I'm touching it. If not, I'll have skipped it. But we need to look at it because of the signs. So x, 2x times x will give us what? 2 what? X squared. You know how we got x squared? I'll show you in the next law. That's from the law of indices, the multiplication law. Now 2x times minus 5 will give us what? Take note of this sign. Minus here, plus here. So it will give us minus what? 10x. So we are done with this part. Let's look at this other part. We have plus 3 here, right? So plus 3 times x will give us what? Plus what? 3x. And plus 3 times minus 5. Plus times minus will give us minus. 3 times 5 will give us 15. Next up, what? Simplify. We have minus 10x and we have plus 3x. We say from algebraic expression, we can add them when they have the same variables. Now they have x and x variable and the same power, raised to power 1, raised to power 1. So we now have what? 2x squared minus 10 plus 3 will give us what? Minus 7x. Then we will now bring this down. Now be what? Minus what? 15. So this is how we what? Expand what? Brackets. Very simple. Very, very what? Simple. Now let's look at another example. Another example. If we're given 3x minus 4 squared, how do we do this? Now our solution, look at this. Our solution will be what? 3x minus 4 times itself, that's 3x minus 4. Because of this square, it simply means we multiply this value by itself. Now when we do that, we will now have what? We'll do the same thing here now. 3 times everything in this bracket, 3x times what? 3x minus 4. Now minus 4 times what? 3x minus 4. You see the process? First of all, you bring it out. If it's raised to power 3, it will be this times this times this. If it's raised to power 4, it will be this times this times this times this. It will be multiplying itself 4 times. So now it's raised to power 2, so we'll multiply 2 times. So let's go. 3x times 3x will give us what? 3 times 3 will give us 9. X times x will give us x squared. Now, we have 3x times minus 4. Plus times minus will give us minus. 3x times 4 will give us what? 12x. We are done with this part. We move to the next part. So now, minus times plus will give us minus. 4 times 3x will get 12x. And minus 4 times minus 4. Minus times minus will give us what? Plus. 4 times 4 will give us 16. Next up, we'll look at both of them. Is there any other x squared here? No, no other x squared. So now let's move to the next variable, x. There's x here, there's x here. So we'll have what? 9x squared minus 12x minus 12x will give us minus 24x. Then plus 16. Plus what? 16. So we are done with what? Expansion of brackets. Expansion of bracket can either come in this form or in this form. If it comes in this form, you first of all change it to this other form, then you spread it out and multiply. So let's look at the laws of indices, then we'll look at logarithms. We're moving. Laws of indices, then we'll look at what? Logarithms. Let's proceed. So now, for laws of indices, we have the first law. Let's say we have a m times an. The base here is a, and the power is what? M. Now, indices simply means it's telling us how many times this base will multiply itself. So a will multiply itself m times, and a will multiply itself n times. So for this law, this is called the what? Multiplication law. For the multiplication law, a raised to power m times a raised to power n will be what? A raised to power what? M plus what? N. Which is what? Multiplication law. Similarly, say 3 raised to power 2 times 3 raised to power 3 to give us 3 into what? 2 plus what? 3, which is what? 3 into what? 5. So this is the first law. So the next law, we have a raised to power m divided by a raised to power n, which will give us what? The opposite of addition is what? Subtraction. And the opposite of division is what? Multiplication. So we will have what? The same base, a. If they are different bases, if it was a raised to power m divided by b raised to power n, this will not work because they are different bases. But because they are the same basis, a, it will not be what? A raised to power n minus n. Since multiplication was addition, division should be what? Subtraction. So this is what? The division law. The division law. So let's take an example. We have an example, 5 raised to power 3 divided by 5 raised to power 2, which will give us what? 5 raised to power 3 minus 2, which is 5 raised to power 1, which is equal to what? 5. Next up, let's look at the third law. The third law is the power of a power law. Let's say a raised to power m raised to another power n. Now, this law tells us that a will be what? M times n, which will give us a raised to power m times n. Okay, so this is what? Power law. Power of a power law. Now, if you have, let's say, 2 raised to power 2 raised to another power 2, it will simply be what? 2 raised to power 2 times 2, which is 2 raised to power 4, and 2 raised to power 4 is what? 16. Next up, we have the zeroth law, which states that any number raised to power 0 is equal to 1. If you write 100 raised to power 0, you still get 1. 1000 raised to power 0 is equal to 1. 532, any number raised to power 0 will give us what? 1. This is called the what? Zero law. So we have listed out of 4 laws. We have 2 more laws, which is what? The what? Fractional law and the what? Okay, let's clean. I'm not supposed to clean that side, okay? Let's clean this part. So we have the fifth law. Now, if we are given, okay, let's look at the negative index law first. A raised to power minus n, which will give us what? 1 over what? A raised to power what? N. This is what the negative index law. Now, they call it negative index because now it's negative, and this thing is called an index, a power, or an exponent. This m here is called an index, power, or what? Exponent. Please take note of that. So negative index law, this is how it looks. So if you have, let's say 7 raised to the power what? Minus 2 will give us what? 1 over 7 raised to the power what? 2, which is what? 1 over 49. Now let's look at another law, the fractional law. Let's say we have a raised to the power m over what? N. We will now have it as what? The square root of what? A raised to the power what? N. So this is what they call the fractional law. Let's use a practical example for that. Let's say we have 4 raised to the power what? 3 over 2. So it will be written as what? The square root of what? The cube root of 4 raised to the power 2. I seen it. To be looking at the cube root of 4 raised to the power 2. The denominator no, sorry. This will be what? Raised to the power 3. Okay, look at it here. So now this will be the what? The denominator will be the root, and the power 4 raised to the power 3 will be here like this. Are you seeing it? So let's proceed. Let's take an example. Let's take an what? Example. Let me think of an example again to give you. Okay, let's say 27 raised to the power minus 2 over 3. Now, from this negative index law, we know that it will not be what? 1 over what? 27 raised to the power what? 2 over what? 3. Since we are getting this, the next thing is to what? Bring this out using the what? Fractional law. So if you read the fractional law, it will now be 1 over the cube root. Since this 3 now is in the denominator, it will now be what? Cube root of what? 27. Now the numerator is 2, it will now be raised to the power what? 2. I seen it. So now we now have what? 1 over what? The cube root of 27 is what? 3 raised to the power what? 2. Then we'll now have our final answer to be what? 1 over what? 9. So please, this can be very tricky, but I need you to understand the step. The denominator will be what? This square. Are you seeing it? I made a mistake here. Alright. Mistake corrected. The denominator, this n, will be outside, which is the square. Then the numerator will be inside. Similarly, look now, 2 is here, the denominator, which is the square root. 3 is the what? Numerator, which is the power. Look at this one here too. The negative will turn into a fraction. 3 is the denominator, which will be the square, the cube root. 2 is the numerator, which will be the power. Then you simplify. So this is where the mistake was. I've corrected it. Please take notes. So let's move on. Next up, we'll be looking at the what? Logarithms and the laws of what? Logarithms. We'll be looking at what? Logarithms and laws of logarithms. So let's proceed. Number 7. Still under algebra. So let's look at logarithms. Oh, you see the light. If you see the light, my energy bulb is still on. Alright, let's proceed. If you can hear me and you can see me, please let me know. I know it's darker now. If you see the light, I can only leave it to turn on the chain. So the logarithms can only leave here to turn on the chain. So take note, a logarithm is the reverse or the inverse of an exponent. A logarithm is the what? Reverse of an exponent. Remember, I told you this is also known as what? Power or index. So it's the reverse. So if we say 10 raised to the power 2 is equals to what? 100 from indices. That means 100 to base 10 is equal to what? 2. So it's the reverse. So now, let's say we have log b, okay, no, log x in base b is equals to y. Log x in base b is equals to what? Y. Now, this base here, this b, is simply what? 10. And what? This y is what? The power. Then this x here is this 100. Please take note of this thing I'm telling you. So we have to get our answer. Our answer will now be what? B raised to the power y is equals to what? X. Now look at it. B is 10, right? 2 now is y. And x is what? 100. So if we have log 100 to base 10, log 100 to base 10, well, our answer is what? 2. Very simple. Log 100 to base 10, our answer is 2. 2 is simply telling us how many times 10 will multiply itself to get what? 100. Very simple. So now let's look at the laws of logarithms. The laws of logarithms. We have the product law, we have the quotient law, and we have the power law. So I'm writing them down. Please take note. The laws of what? Logarithm. Let me see if I can turn on my lights. Alright. This should be better. The laws of what? Logarithm. So for the first law, which is the product law, this law states that log xy in base a is simply what? Log x base a plus log y base a. Similarly, for the second law, we have the quotient law. Okay, they brought back the light. Alright, for the quotient law, we have that log x divided by y. Quotient simply means division. To base a is equals to what? Log x in base a minus log y in base a. And finally, the third law, which is the product law, which is the power law, power law, which says log x raised to power k in base a is simply equals to what? K, which is the power, come out, log what? X in base a. So please take note of these laws. Take note of these laws. So let's solve an example. Let's solve an example. Then we'll move to the next topic. The next topic is Surds. Let's just solve an example on these laws very fast. The next topic is Surds. So we say we have an example. Solve for or let's not use solve for, let's say simplify log 16 base 2 plus log 4 base 2 minus log 8 base 2. Now we have this log 16 base 2 plus log 4 base 2 minus log 8 base 2. So our solution, now looking at the laws, you observe something. Let's apply the first law, that's the product law, to the first two terms. So if I apply the first law, we'll now have that log what? 16 base 2 plus this will now be what? 16 times what? 4 in base A, in base 2, sorry, not A, this is 2. 2. So they have the same base, so we can apply the first law. You know, when they're adding, it simply means multiplication. So we'll now have what? Our answer is log what? 16 times 4 will give us what? 64 and in base 2. Now let's look at this other part of the expression. We have changed this 2 to what? Log 64 in base 2. So our new equation will now be what? Log 64 base 2 minus what? Log what? 8 base 2. Now we've changed this to this. So we now have this, right? So if we apply the second law, which is the division law, right? We will now have that this is the multiplication law. So for the division law, we'll have, since they have the same base, log, they have the same base, it will now be base, it's now the log, this one, that's 64 over log 8. Negative simply means division, so it will be over log 8 in base 2, common basis. That's 64 divided by 8 will give us what? 8. Now, we've gotten what? Log 2 in base 8. But we're not done. Now you ask yourself, how many times will 2 multiply itself to get 8? Let's do that. 2 times 2 is what? 4. Times 2 is what? 8, right? So it's 3 times. So now our answer will be what? 3. So we are done with this question. We are done with this question. When you see this question, you group them. You take the first group, you apply the multiplication law. When you get your answer, you take the second group, that's this one, you apply division law, you get your answer. Then when you get your answer, you do what? Use the law. Use the definition, which says that logarithm is the what? Inverse of exponent. So if 2 raised to power 3 is equals to 8, that means log 8 in base 2 will be equals to what? 3. Very simple. So let's move on to Surds. Let's move on to what? Surds. Let's move on to Surds. All right. Surds. Now let's ask ourselves, what is Surds? In Surds, we look at two things: simplification and rationalization. Simplification and rationalization. We look at two things: simplification and what? Rationalization. Now, a surd is an irrational root. Take note. A surd is an irrational root. Take note. Example. We have root 2, root 5. These are surds. But if you say something like root 4, root 16, these are not surds, these are surds. Why? Because the root 4 will give us what? 2. And root 16 will give us what? 4. So they are not surds. For this now, we cannot do root 2. We cannot do root 5. So these are surds. Know the difference. So now, let's move on. For surds, let's take an example now. Example. They ask us to do what? Simplify root 72. Simplify root 72. Now, the first thing we need to look at is that how can we break this 72 down into, how can we simplify it down so that we can what? Take the root of 1 and be left with the original. Now the first step to do is what? Find the factors of 72. So our solution will be what? Step 1. Step 1. Find the factors of 72. Find the what? Factors of 72. Factors means the numbers that divide what? 72. Now, if we take the factor of 72, let's say 2 into 72. 2 into 7 will give us what? We take 2, right? 2 divided by 7 will give us 3, remainder 1. If we take 1 here, it's now be 2 into 12, which will give us what? 36. Alright. Let's look at this 36 now. If we take the square root of 36, what are we going to get? The square root of 36 will simply give us 6. Now, we use 2, right? So it's supposed to be what? It's supposed to be what? 72 is equal to what? 2 times 32 times 36, right? They are the same thing. And we know that if we take the square root of 36, we'll get 6. So this will go, this will go. Now, this will go because this is a perfect square. This is a perfect square. 36. 6 now. The perfect square of 36 is what? 6. So let's go. Let's go, let's go, let's go. So we'll now have 72 is equal to what? Is into what? Is equal to what? 36 times 2. Now, since we have 36, since we have the square root as 36 times 2, we will now break it down. 36 times what? Root 2. So we are putting our solve here. So we will now have what? 6 what? Root 2. 6 what? Root 2. So that's how we would simplify this kind of questions. Very simple. So we have done simplification. We have simplified this sort to get what? The simplest form, which is what? 6 root 2. So the first step, take the factor of 72. Make sure that when you take the factor of 72, you get the perfect square and another number that cannot be what? Broken down. Now, this is the number that cannot be broken down. This one, we have 6 as it. So now let's look at another example under what? Rationalization. Another example under rationalization. Let's go. So for this example, we have 5. We have what? Rationalize 5 over what? Root 3. Now, the first step, our solution will look like this. Our solution will look like this. When we look at this now, first of all, we cannot have a square root sign in the denominator. It is very, very wrong. So in order to eliminate this square root sign, we need to what? Rationalize the what? Denominator. And how do we rationalize the denominator? We multiply both the numerator and the denominator by this denominator. So we'll have that 5 root 3 will be equal to what? 5 into what? Root 3 times root 3 over what? Root 3. So if we multiply this, we will now have what? 5 root 3 into what? Root what? 3 times 3, which is what? 5 root 3 into root 9, which is what? 5 root 3 into 3. I seen it. So this is how we have eliminated this. We've eliminated this sort in the denominator because the denominator cannot have a square root sign. So this will be our what? Rationalized form. So we are done with this example. So moving on, we'll look at linear equations. Linear what? Equations. Let's look at linear equations. Linear equations. So after linear equations, we will look at simultaneous equations. So now for linear equations, what do you understand by a linear equation? Now take note, for this linear equation, we're considering only one variable. Remember, I told you a variable, I defined a variable earlier. So you should know that a variable is simply an unknown. So a linear equation is one where the variable, usually x, has the power of what? 1. That means it is linear. The power of the variable must not be greater than what? 1. So a linear equation is what? 1 where the variable A linear equation is one where the variable, usually x, has a power of 1. Our goal is to what? Isolate x. Get it all by itself so we can know the value of what? X. Now, the golden rule. The golden rule. Take note. The what? Golden. Simple. If we have a number and it's on this part of this equation, let's say the number is having a sign addition. If you take it to this other part, it becomes what? Subtraction. Similarly, if we have subtraction, if you take it to this other side, it becomes what? Addition. These are the golden rules. Please take note. We'll use them while solving. Very simple. So let's go. Solve for x. Now we are solving for x. And we have what? 3 into x minus 4 is equals to 15. Now, before we're talking about expression, take note. And when we're talking about expression, we do not have any equals to sign. But now we're talking about equation, so we have an equals to sign. And now they say we should solve for x. That means x is missing. X is the what? Variable. And if you watch, we said for linear equation, the variable must have the power of 1. So now x is raised to the power of 1. If it's greater than 1, it's not a linear equation. If it's 2, it's called the what? Quadratic equation. So now the first step to do here is to what? Expand this bracket. If we expand this bracket, we have 3 times x will give us 3x, 3 times minus 4, plus times minus equals minus, 3 times 4 equals what? 12, equals to what? 15. The next step, we are trying to isolate x to be on its own, so we can get the value for x. So we take minus 12 to this other side. And I said that if you're taking minus to this other side, it becomes what? Positive. So we have 3x equals to what? 15 plus what? 12. 3x is equal to what? 15 plus 12. 12 has gone to this side and to change to what? Positive. So we now have 15 plus 12, which will give us what? 3x into what? 27. Now, the next step is to do what? Divide both sides by 3 to eliminate this 3 on this side. Anything you do to the left hand side, you must to the right hand side. So let's go. Divided by 3. Divided by 3. 3 will cancel 3. So we have isolated x. So x will be left alone. So x is equal to what? 27 over 3. 27 divided by 3 will give us what? 9. So we have that x is equal to 9. Very simple. So now let's take one more example. Let's take one more example on linear equation before we move towards simultaneous equation. Let's take one more example. Now, this example is solve for x, still solve for x, 5x plus 4 is equals to what? 2x plus 19 plus what? 19. And solve for x. But now, x is on this side, the left hand side, and x is on the what? Right hand side. So what do? We'll bring all the x to one side and take all the constant, all the numbers to another side. We are trying to eliminate x. So let's take this x here. We'll now have our solution to be what? 5x. If we're taking 4 to this other side, right? So let's ignore that 4. Bringing 2x to this other side, 2x is positive. If you take it to this side, it's turning to what? Negative. So it will be minus 2x is equals to, we're taking this 4 to this other side, it will now become negative 4 plus what? 19. Hope you understood what we did here. We took this one here, and we took this one here. That's how we got this. And as you're taking them, the sign is changing. That's the golden rule. So 5x minus 2x will give us 3x. Minus 4 plus 19 will give us what? 15. Divide both sides by 3 to eliminate this 3 here. What you do to the left hand side, you do to the right hand side. 3 will go here, 3 will go here. So we'll be left with x is equal to what? 15 over 3. So x here will cancel. 3 will enter here to get 1. 3 will enter here to get what? 5. So x is equal to what? 5. So this is it about linear equation. Very simple, right? So let's move to what? Simultaneous equation. Simultaneous equation. Simultaneous equation. Simultaneous equation. We're almost done. Simultaneous equation is number 10. We'll stop at number 12. Simultaneous equation. Now, for simultaneous equation, we are working with more than one variable. So let's write 2 variables. So once you see more than one variable, before we had only one variable, which was x. Once you see more than one variable, then we will use what? Simultaneous what? Equation. Now, for simultaneous equation, take note. Simultaneous simply means at the same time. Simultaneous simply means what? At the same time. You are working on 2 things at the same time, 2 variables. You are giving 2 different equations. You are giving 2 what? Different equation. And you are working on the both of them at the same time. And you have 2 unknowns. X and y. So take note of all these things I'm saying. At the same time, 2 different equations, 2 unknowns. So now, you need to find the specific pair of numbers that make both equations true. We have 2 methods. 2 methods of simultaneous equation. 2 what? Methods. Please take note. For the first method, we have substitution method. And substitution method simply means solve one equation, find one variable, and plug it into the other variable. So you what? You find one variable and what? Plug it into the other equation. Very simple. Find one variable, plug it into the other equation. Number 2, the second method we have is what? Elimination method. Now, for elimination method, you simply add or subtract the 2 equations to kill off one variable. So for elimination method, you what? Add or what? Subtract. Either add it or you subtract the 2 equations to what? Kill one variable. So you what? Add or subtract the 2 equations to kill one variable. You can either decide to kill x or you decide to kill what? Y. So let's take an example. We'll take an example on each of them. Let's take an what? Example. So now the first example will be on elimination method. Example 1. Elimination method. now for this, they say we should solve for x and y since there are two variables, x and what? Let me use and, let me not use this sign, and y. So now, solve for x and y. We are given two equations. The first equation is what? 2x plus y equals to what? 10. And the next equation is what? X minus y is equals to what? 2. Now, we are going to use elimination method to what? Solve for this equation. So our solution will be what? This will be our solution. Look, watch closely. So this will be our solution. So the first step, step 1, the first step, observe y is positive here, y is negative. So if we add the both of them, we can what? Eliminate y. And now the coefficient of y here is 1, the coefficient of y here is what? 1. But here the coefficient of y is of x is 2, the coefficient of x is what? 1. And their signs are the same. So y is the easier target here to eliminate. So first of all, you observe your equations. Look at the one that's easy to eliminate. The one that has the same coefficient. If it was not the same coefficient, it will not work. We have to what? Either multiply them by the coefficient of one of the what? Variables. So now, since y has the same coefficient, let's go. So we'll have what? 2x minus x. We will now have what? Y minus y. And we'll have, okay, we're adding it. We're adding them. Let's not do it like this. Let's do it this other way since we're adding it. Now, if we are to add these two, this marker. If we are to add these two now, x plus x will give us what? 3 what? X. Now, plus y plus minus y. Plus times minus will give us what? Minus. So it will be plus y minus y, which is what? 0. Is equals to what? 10 plus 2 give us what? 12. Very simple. So now we're left with what? 3x is equal to what? 12. Now divide both sides by 3. We'll have 3 into here, 1, 1, and x is equals to what? 12 here, give us 4, here give us 1. 3 into 3 will give us 1. Take this value of x, the second step, take the value of x and put into. Now let's put it into equation 1 or equation 2, depending on your choice. If we put into equation 1, we have 2x plus y equals to 10. Our value for x is 4, right? So now we put 2 into 4 plus what? Y is equals to what? 10. 2 times 4 is 8 plus y equals to 10. Take 8 to this other side, become negative. So y equals to what? 10 minus 8. And y is equals to what? 2. Very simple. So this is how we use simultaneous. This is how we what? Simplify simultaneous equation and solve for x and y using what? Elimination method. So next up, let's look at what? Substitution method. Let's look at substitution method. Let's look at substitution method. Substitution method. Example. So for substitution method, we have an example. We are giving two equations because note, we are always giving two equations. We say we should solve for x and y again. See the same thing. Solve for x and what? Y. And we are given this equation. We are given the equation as y is equal to what? 3x minus 1. And we are given 2x what? Plus y is equal to 14. So now, like the name says, substitution. But you cannot substitute unless you put the equation in terms of either x or y. Now, we are going to the equation. The equation already is in terms of y. We know that y is equal to 3x plus y. But now, in the second equation, we have two variables, x and y. So since we already know that y is equal to 3x minus 1, we'll put it into this second equation. So anywhere we see y, we'll put 3x minus 1. So now, this second equation will be in terms of only x. Are you seeing the difference between elimination and substitution? So let's go. So we now have that 2x plus y. Now, this y now will now take 3x plus 1. 3x minus 1, sorry, not plus 1. Which is equal to what? 14. Which is equal to what? 14. Next up, we'll expand this bracket, open up the bracket. We'll now have what? 2x plus times this will give us plus 3x plus times minus 1 will give us minus 1 equals to 14. Now we'll take 1 to this other side, we'll be left with 2 plus 3x will give us 5x equals to what? 14. This one, take it to this other side will be what? Plus 1. So we'll now have 5x is equals to what? 15. To get x, we'll divide both sides by 5. 5 into here will give us 1, 5 into here will give us 1, 5 into here will give us 1, 5 into here will give us 3. So we'll be left with what? X equals to what? 3. So we have gotten our value for x. Now, what's closely? The second step is to what? Take the value of x and put back into the equation to get what? Y. And we have y as 3x minus 1. So our new y will be what? Y equals to what? 3x. X is 3. So it's 3 into 3 minus 1. 3 times 3 is what? 9. 9 minus 1 is what? 8. So we have that y is equals to what? 8 and x is equals to what? 3. So we are done with what? Simultaneous equation for both elimination method and what? Substitution method. So next up, we'll be looking at quadratic equation factorization, how to get the roots of a quadratic equation, and finally we'll be looking at inequalities and we'll call it a what? Day. Let's go. I'll call it a what? Day. All right. Let's go. That's by 11. This marker is going out. Quadratic equation factorization. Now, we are given an equation. What's happening to all my markers now? Go ahead. Markers. They say we should solve x squared minus 5x minus 6 equals to 0. Now, this is under quadratic equations. And what? Factorization. Now, note, this method, just like the other one we used earlier, when I was showing you how to factorize a quadratic equation. But now, this is different. This is kind of what? Different. Alright, let's take out this expression first. Remember, everything must be equal to 0, right? So we need to get this expression out, factorize it, then equate it to 0 individually. So if we take out x squared minus 5x minus 6, so now the coefficient of x is 1. 1 times 6 will give us 6. Now the factors of 6 is 1, 2, 3, and what? 6. Now we need two numbers that when we add them, we get what? Minus 5. Now, 1 plus 6 cannot give us 5, cannot give us minus 5. Even though we do minus 1 minus 6 will give us minus 7. It will not work. 2 and 6, 2 plus 6 will not give us, it will give us 8. Minus 2 minus 6 will give us minus 8. 3 plus 6 will give us 9. Minus 3 minus 6 will give us 9. That one cannot go. Let's go. 2 plus 3 will give us positive 5. So it will not work. We need negative 5, right? So minus 2 and minus 3 will give us what? Minus 5. Take note. So we left with what? X squared minus 2x minus what? 3x minus 6. Now the next step is to what? Take them as pairs. The first pair is x squared minus 2x. So from this pair x squared minus 2x, what is common between both of them? We know that x is common between both of them, right? So we bring it out. X into x squared will give us what? X. X into x squared simply means x squared over x. X here will give us 1, x here will give us what? X. So x into 2x is what? X over what? 2x over x. X here will cancel x. We'll be left with what? Minus 2. Are you seeing it? Now, we take out the second pair. The second pair. To take out the second pair, we look at the both of them. What is common between both of them? What is the common factor? That's the HCF. The highest common factor between both of them is 3. Right? So now, we take out what? Negative 3. Minus what? 3. So now if we do minus 3x over minus 3, minus will cancel minus to become plus, 3 cancel 3, so we left with what? Positive x. Now take out this one again, minus 6 over minus 3, minus will cancel minus, 3 cancel 3, 3 will cancel 3, we get 1, 3 cancel 6, we get 2. So we what? Positive 2. The negative, watch, the negative have cancelled out each other. We took out minus 3 here, so minus 3 is the highest common factor between these two. I see this pair now, this second pair. So now, if we do this, no, this is supposed to be negative. Sorry. This is supposed to be negative. Thank you. Why is it supposed to be negative? Because if we do negative times, oh my god. This marker is not working. Sorry, I need to change all my markers. I need to change all my what? Markers. I think I'll use blue marker. Permit me to use blue marker. Okay, this one is writing. Alright. So since we use negative here, this is positive. We got positive, right? So 3 minus 3 times x will give us minus 3x. This times will give us this. But we want to make sure that these signs in between both of them are what? The same. We want to make sure that the signs in between both of them are what? The same. So now, let's look at this. This one now, we took out x. X into here will give us x. X into minus 2x will give us negative. So let's change this one to what? Positive. Let's change this one to positive. Let's take positive of 3. So positive of 3 into here will not be what? There's an error in this equation. I said this should be a positive, not a negative. It's from the equation, sorry, pardon me, it's from the equation. I just check the equation now. The equation is supposed to be a positive. The equation is supposed to be a what? Positive. Please take note. So here, let's do this part alone. The equation is supposed to be a positive. I seen it. The markers are just frustrating me. The markers are really frustrating me. Okay, this is supposed to, from the question. This is from the question. Please take note. I made a mistake while writing the question. So now, since it's from the question, we can still take our common factor as what? Minus 3. So minus 3 over minus 3, minus 3x over 3, minus 3 will be what? Minus will cancel minus. 3 will cancel 3, we'll be left with what? X. Next up, take out 6, 6 over what? Minus 3. 3 here will give us what? Minus 1. 3 here will give us 2. So we have what? Minus 2. Alright, so let's move on. Let's move on. So we take out these 2, we now have what? X minus 3. These 2 are common. We now write what? X minus 2. Remember, they are all equals to what? 0. So now, we now have what? X minus 3 is equals to 0. And what? X minus 2 is equals to 0. That's why they call it what? Quadratic equation. That means to have what? 2 different roots. So if we take minus 3 to this other side, it's now be what? X equals to what? 3. And if we take minus 2 to this other side, x equals to what? 2. So I see the 2 different roots of x. That's why it's called a quadratic equation and not a what? Linear equation. So let's go to the final thing we have for today, which is what? Inequalities. Inequalities. Let's go. The last thing before we call it a day. The last thing before we call it a day. Inequalities. Inequalities. Last topic we have for today. All right. So for inequalities, okay, I said we'll use 2 methods of factorization. Now, the second method of quadratic equation is the what? Formula. Remember the almighty formula which says x equals to what? Minus b plus or minus square root of what? B square minus 4ac all over what? All over 2a. Now, from that former equation, we know that we had x squared minus 5x plus 6. Now, in this one, a will be the coefficient of this first term, which is 1. B will be the coefficient of this second term, which is minus 5. And C will be the coefficient of this. This is equals to 0. C will be the constant, which is 6. You simply what? Input the value of 1, 5, and 6 into this almighty formula to get the value of x. And when we put the values here, we'll still get the same thing as x is equals to 2 and x is equals to what? 3. You can try it as an assignment. So let's move to inequalities before the marker will finish. Let's move to inequalities very fast. Inequalities. All the markers are not coming out again. Inequalities. The marker, it's not coming out again. This one is trying. Okay, we can manage this one. We can manage this one. Okay, we can manage this one too. Alright, let's look at inequalities, then we'll call it a day. Inequalities. For inequalities, we have linear and quadratic inequalities. We have linear and what? Quadratic inequalities. For the linear inequalities, take note, inequalities use symbols like, they use symbols like greater, less than, greater than, less than or equals to, greater than or equals to. Now, you solve it like a normal equation. Take note. When you are solving inequalities, the same way you are solving your linear equation and your quadratic equation, that's the same way you solve your inequalities. The same way. But you need to note something very critical. If you multiply or divide, whenever you are multiplying or dividing by a negative number, please bear with me, the marker is not coming out again. After this one, we are done. We have just 5 minutes or less to spend here. You must flip the inequality sign. Oh my God. So you must what? Flip the inequality sign. Whenever you multiply or divide by a negative number, you must what? Flip the inequality word sign. So let's solve an example. Let's solve an example. Now, say solve an example, right? So we'll solve 5 minus 2x is less than or equals to what? 11. Now, since you are solving exactly like a quadratic equation, so our solution will look like this. Solution 5 minus 2x less than or equals to 11. We will now take this 11. Our goal is to find x. Since you are looking for x, we'll first of all carry this 5 to this other side. So we will now have what? 2x less than or equals to 11. Since you are taking 5 to this other side, it becomes what? Negative. The same way we do in our what? Quadratic equation. It becomes what? 11 minus 5. Now, 11 minus 5 will now be 2x minus 2x less than or equals to what? 11 minus 5 is what? 6. So now, from that law or that rule, if we are dividing by a negative number, now we have a negative number here, minus 2. If we divide both sides by minus 2, minus 2, minus 2, this sign will change. So minus 2 cancel that here, minus 2 cancel that here. So x will be left with what? This less than sign will not change to what? Greater than or equals to. So minus 2 here will cancel out 6 and we'll be left with what? Minus 3. I see the change in sign. This is for what? A linear inequality. Similarly, if we have a quadratic inequality, let's say we are given x squared minus x minus 6 is equals to is less than 0. Sorry. Now, what do we do here? Now, look at the critical values. First of all, we use the same logic. Bring out this expression, solution. Oh my God. Solution. We bring out this expression, x squared. Oh my God, why is this thing doing like this now? X squared minus x minus 6. The coefficient of x squared here is 1 and our constant is 6. So 1 times 6 will give us what? 6. Now take the factors of 6 as 1, 2, 3, and 6. We need two numbers that when we add them, we get minus 1, which is the coefficient of this middle term. Now, if we do 1 plus 2, we cannot get it. If we do minus 1 minus 2, we can't get it. But if we do plus 2 minus 3, plus 2 minus 3, I see it. Plus 2 minus 3 will give us what? Minus 1. Then plus 2 times minus 3 will give us what? Minus 6. So our factors will be what? X squared. We're almost done. In less than 2 minutes, we'll be done. This marker is the one keeping us here. If not, we'll be done for today. This marker is just the one keeping us here. And I don't know how 4 markers, I mean 5 markers, will just be decide to misbehave at the end of the class. I don't know why. So we'll be left with what? X squared. Oh boy. X squared plus 2x minus 3x minus 6. Take out this first pair. We now have x is into what? X divided by x squared will give us x. X divided by 2x will give us what? Plus 2. Into here, we'll have what? Minus 3. And we'll have what? X plus what? 2. We'll now have what? X minus 3 and x plus 2. I think we've gotten x minus 3 and x plus 2. We'll now equate both of them into this inequality. And if we equate both of them into the equality, which is 0, we'll now have, if we take this one to the other side, we'll have that x is what? X minus 3 is less than 0. If you take minus 3 to the other side, it's going to be x is what? Less than 3. And second equation will be what? X is less than what? Minus 2. So, thank you for staying to the end of today's class. Please, if you have any question, please drop it in the comment section, or you can drop it on our WhatsApp group. Yes, this class was hosted in collaboration with the JAMB Master. So please, this is day 1. This is what? Day 1. By tomorrow, I'll get new markers, so I will not experience this kind of problem. Please, I sincerely apologize for this break in transmission due to the marker. So please, thank you. In case you're new to this channel, please make sure you like, you share, and you subscribe. Thank you, and see you in our next section. Bye for now. One more. This marker has done wonders today.